Hello, and thank you for being here today. I sincerely appreciate it. My name is James Malone. I'm a product manager with Google Cloud. And today I'm going to be joined by Zulily in just a little bit. And I want to talk through the topic of digging and filling data lakes. Specifically, I want to talk about how you think about data lakes, why people create data lakes, the value they can provide, and what they mean in terms of architecture on Google Cloud Platform. So roughly, we're going to frame what are data lakes, what do we mean? Data lakes could mean a lot of things, so I want to fill in specifically kind of what we're thinking about, what we're talking about. I'm going to talk about if you wanted to go build a data lake on GCP, what does that actually look like? And then Zulily is going to come on stage and walk through their data platform, which will give you an indication of how somebody has built a data lake in Google Cloud Platform in a real-life scenario. So first, what are data lakes and why do they matter? And it's a common phrase, so if you're familiar with data lakes, I apologize, but I do want to level set just so we form a common understanding of what we mean by data lakes. So first and foremost, data lakes are a collection of raw data. They could be unstructured data, they could be structured data, they could be semi-structured data. It's really just a collection of data that you've put in a single store for a variety of purposes. So data lake is a good term. You could look at it as a giant container of data. It's essentially a collection of data that you're going to use for some purpose, and it is in some format. Data lakes typically have a few key features. First, people often put a lot of raw or unprocessed or pre-processed data in a data lake. So it's very common for people to take all of their data and as a first step, just land it in a data lake until they know what they want to do with it. Second, it's very common for data lakes to have a mix of structures. So you may have a data lake that has a lot of unstructured data, but it's also sprinkled with semi-structured or structured data after it's been processed or in the middle of being processed. Data lakes, third, are not tied to processing. So data lakes are kind of the hallmark of the separation of storage and compute. So when you store data in a data lake, it's not tied to any specific processing technology. And most commonly, you'll see that there's actually multiple processing technologies that are used against one data lake itself. That leads to data lakes being multi-purpose. Instead of having one specialty function, being really good at one thing, data lakes are kind of a jack of all trades in terms of a data store. They might not be the best in one particular function, but they serve a lot of functions very well. Why build a data lake? Well, first, scalability. Data lakes are usually very scalable. So instead of worrying about things like how much capacity do I need or how many disks do I have to buy, instead you just think of a data lake as almost an infinite store. Second, there's less upfront work required. A key hallmark of data lakes is that you can just put data in without thinking too much about it. You're not having to pre-process the data or pre-apply schemas to data, not having to follow any particular formatting rules. Data lake really, in an ideal sense, should just be as simple as putting the data in a store and you're done. You can use a variety of tools with a data lake. So a good data lake will have APIs built on top of it. It will have third-party integrations that you can use with it. A data lake should be connected. A data lake off by itself or usable only by a specific set of tools, that's not a great data lake. That's just a really isolated data silo with maybe more data in it or a variety of data. Because it is well connected, sort of infinitely scalable, it should really be usable in a variety of circumstances. That means organizational circumstances. It means in terms of applications. So you might use the data for analytics. You might use the data for ML. You might use the data just for archive and disaster recovery and retention. All of that is done in a data lake with cost in mind. So a real big reason that a lot of people are interested in data lakes and build data lakes is cost. Often when you reason about what data to keep or not keep, you're trying to think about, well, how much does the data cost? Is it worth the data sitting around? Maybe I'll use it, maybe I won't. Data lake theoretically should remove as many of those cost concerns as possible. So data lakes sound great, and a lot of people talk about data lakes, and there's a lot of interest in data lakes, but there's a very fair question of, if data lakes are so great, why isn't everybody building them? Or why doesn't everybody already have a data lake? Well, I would postulate there's a few reasons for that. One of the biggest reasons I would attribute to Conways Law. Simply put, your organizational structure will often define how you organize, in some cases, applications, but I'm going to apply it to data. So essentially, your organization chart influences how you think and break apart data. So in this very simple example, you have a set, let's say these are different departments inside of an organization. They're going to have their different applications. They're going to have their different technologies. They're going to have their different needs, all very legitimate, all very valid. That's their view of the world. Unfortunately, that siloed view of the world is driving their technology choices. It's driving what data storage technology they're thinking about, what processing tools they're using, how they think about structured or unstructured data. So without really thinking about it, the organizational chart is actually almost clearly mapping to the technology choices that they're going to make. That makes data integration really messy. So now you have all of these technologies, you have some data that's unstructured, you have some data that's structured, and it usually creates a really big plumbing mess that you then need yet another group to go and fix. So you have 3 different databases, 2 data warehouses, raw data just sitting everywhere, and now you need a massive effort to go and try and tie all of this together. Now, I think it's fair to say most people don't wake up in the morning and think, I'm going to go create just a giant data mess for myself, because that sounds like fun. Instead, it's their organizational chart that's usually driving a lot of decisions behind the scenes, and they just end up in a mess. Data is also, as a result of kind of being organizationally driven, it's not seen as an asset. It's usually seen as a cost in a lot of aspects. So you're thinking about, okay, what technology do I need to store this data? And then data becomes a cost center, and people are buying technology to store the data, but at the end of the day, you're really just trying to think about how can I lower my costs, so how do I optimize costs versus data being kept? And instead of actually deriving value from your data, you're just sitting there trying to do accounting on your data. And I think it's fair to say that most people don't find a lot of value out of doing accounting on their data unless they're dealing with financial data, and that's their goal. It also means that any duplication is highly inefficient. So if you have 2 groups that are storing data, when everything is a cost, any duplication inside of 2 technologies that groups may not even know exist outside of that particular group is extremely inefficient. It also makes management a complete headache. So you have all of these different organizational groups. They have all of the different applications that are not only storing but using data. They have all of these different retention policies they may want to apply to data. They have different security requirements, different retention requirements. So it usually leads to programs where you have to look at an organizational view of the world and profile who has data, how much data do they have, where is that data located, what are their retention policies, what is their security policies, what are their schemas. Quite frankly, this usually leads to large-scale efforts that take multiple years to try and create a data map across an organization. Again, might be a worthwhile effort, and it's something that people have to do to make the world a better place organizationally, but it's distracting from what most people want to do, which is just actually use data and drive value from their data. A common solution to this problem is the drive to data warehouses. And I'll preface this with saying data lakes and data warehouses coexist. So this is, don't interpret this slide saying data lakes and data warehouses are diametrically opposed. They actually coexist, and there's really good reasons why you actually want both. But a common knee-jerk reaction to kind of the data messiness that's driven by all of this organizational complexity is centralization. And a very common form of centralization is creating a large-scale data warehouse. And then you take all of these efforts, and then you design schemas that are cross-functional, and you have committees that try and figure out what schemas you need and how you break everything apart. You may derive value from the data warehouse, but that also introduces its own complexities in terms of cost, in terms of getting everybody to agree on what schemas you want, in terms of access. So just driving to a data warehouse as an end result makes sense in some cases, but not all cases. So data lakes can simplify and optimize for these problems. Very simply, a data lake can break down organizational walls. So it seems very simple because it is actually a pretty simple concept. Instead of focusing on different data technologies because you have these organizational silos and you have people thinking kind of in a box, with a common store, with a common data lake, if you put data in that data lake, it's much easier to think about. It's much easier for teams to see what other teams have. It's much easier to store that data. It's much easier to think about security, much easier to think about retention. All because instead of trying to silo data and partition it across different technologies, different processing tools, you're putting it in one data lake. I mentioned that data lakes and data warehouses are complementary, and that is very true. So we'll talk about how data lakes and data warehouses are complementary inside of GCP, but they both have their purpose. A data lake is a great single shared common resource. It's a great place to store data of all types. It's really in many cases, jack of all trades, master of none. Data lakes can be read from many applications. Data lakes have a great utility in storing data until you know what you want to do with it, or until you load it into a subset of data and often put it into an application or a specific purpose. Now, data warehouses are really good at what they do. There are very good reasons why you would want to take a subset of data and apply schemas to it and have sub-second or very low latency queryability on that data, ensure that the data is clean, is formatted, is consistent. Data warehouses are very, very good at that. Data warehouses are not very good at just storing lots and lots of data, because you go through the process of loading that data, normalizing that data, and applying schemas to that data. Likewise, data lakes are not great at offering sub-second queries. Even with tools like Hive, or in some cases Presto, you may get to lower latency queries, but they're not going to generally match the semantics of data warehouses. So both of these tools are very complementary in a data-driven organization. I want to talk through how you would build a data lake on GCP if you were to get started today. And this is coming from the assumption that you just don't have kind of any data in GCP at all. I mentioned a hallmark of data lakes is that you have the single store of data. And in Google Cloud Platform, cloud storage is the hub or the central spoke of a data lake. And there's a lot of semantics tied to cloud storage that make it the central hub or spoke for your data lake. First, you can use it across many, many products. Cloud storage is well connected and well integrated to many cloud platform products. You can optimize your cost and availability based on different availability tiers or different storage tiers inside of cloud storage. I did, in fact, count the number of nines because I was curious, and there's 9 nines after the decimal. There's very high durability in cloud storage. You don't need to think about how you're going to necessarily back up your data or what happens. It's incredibly durable. You can also apply centralized management and security policies. So if you've not used cloud storage before, you can apply policies on buckets, you can apply policies on objects. You have a lot of flexibility to specify what happens to items. And inside of a data lake, that's nice because you can do that in a central place instead of having to figure out whichever number of technologies you're using to try and figure out then how to apply policies to them. Something that some people know about that's not obvious, but one of the most interesting features for cloud storage is immediate consistency. And I'll talk about this as it pertains to the Spark and Hadoop ecosystem, which I know quite well. But immediate consistency is actually really, really important in a data lake. The best way to summarize immediate consistency is when you put something in the data lake, in this case cloud storage, it's immediately available through a list operation in cloud storage. This is really important because if you have multiple producers and consumers that are pointing at the same bucket, if somebody puts a file there and you want to immediately process that file, you want that file to be immediately available in a list operation. Otherwise, somebody may miss it. Or worse, if one person gets it in a list operation, another person does not get it in a list operation, all of a sudden you have discontinuity between two different users of your data. So the fact that cloud storage has immediate list consistency is actually really, really important. In terms of thinking about a data lake, the different storage classes in cloud storage are very, very important semantic for building a data lake on GCP. There's a couple of really important points to take here. First, there's a single consistent storage API and availability across all of these storage tiers. So instead of having to try and reason and think about, do I use regional buckets or cold line, and how long does it take to get something out of cold line, or what different APIs do I need to use to access cold line versus nearline? You don't have to think about different APIs. You don't have to think about latency for getting things out of cold line, so you don't need to introduce seconds, minutes, hours for getting data between these availability tiers. The availability tiers also allow you to pick and choose. Sometimes there are very valid reasons why you want things available very, very quickly. There are a lot of times you may want something available, you may want something that costs less, but you're going to access less frequently. So in a lot of cases, people will take archive data that they don't expect to use, and they'll put it in cold line. You can also apply policies on buckets and on objects, and that's actually really important. So in this case, say you have a bunch of things, and you keep them in a regional bucket, and then after 30 days, you want to put them in nearline. You keep them in nearline for 30 days, and then you put them in cold line for a year. This is really important because this is actually very similar to how a lot of organizations think about and use data. There's generally only a subset of data which they're using with any regularity. It's very uncommon for people to use all of their data all the time. It's very common for people to access or work on their most recent data most frequently, and they still want access to their older data, but they don't necessarily need access all the time, or access is very, very infrequent. And there's a lot of reasons for that. The data that people produce changes over time. The trustworthiness or accuracy of the data may change over time. Doesn't mean you want to get rid of the data. It just means that you don't necessarily need access to it all the time. Data lakes fit into a flow, thinking about data. So when you ingest data, it's very, very common to ingest data into that data lake and then try and figure out, or maybe you already know, but that data lake is there until you take action on that data in some way or some form. So for example, you may ship all of your logs, all of your blob data, you may have images, store all of that in your data lake. In some cases, people already know what they want to do with that data, and they just take a subset of that data and process it and put it in maybe a transactional database or some front of house system. In other cases, people may want to keep data in that data lake until they know what to do, and that's the power of a data lake. It gives you that flexibility to keep the data at rest. You may immediately act on a subset of it and put it in a particular place, and you only have to act on a subset of it. You don't have to keep the whole data chunk in one piece, putting it in a more specialized system. Or you can just keep the data there until you know what you want to do with it. There's multiple places where you may want to think about loading and reading data inside of Google Cloud Platform. There's a lot of text on this slide. Thankfully, a lot of people are taking pictures of the slide. All of this is also documented online in a guide that I will post a link to at the very end here. But the key point I want to make here is GCS as the center of your data lake is great for just storing large amounts of data. There are other storage products that you can use for more specific needs, so application-based needs. You may want data inside of an enterprise data warehouse and you load it into BigQuery. You may want to put data inside of Cloud Spanner, but most likely you're not going to want to put all of your data in Cloud Spanner, or all of your data is not appropriate for Bigtable. So with cloud storage, you can keep all of your data in a centralized data lake and then use each technology appropriately for a very specific purpose. There's multiple ways that you can fill cloud storage. So hypothetically, say you have a lot of data that's just existing somewhere in the known universe. There's batch ways you can load that data. So you can use GSUtil, which ships as part of the Google Cloud SDK. There's a storage transfer service. You can use something like DiskCP if you're using the Spark and Hadoop ecosystem. And it's actually, that's very, very common for people that are moving data from HDFS to cloud storage. You can stream the data using something like PubSub and Cloud Dataflow. There's also a transfer appliance. There's also a number of partners who can help you move data to cloud storage in both a one-time and replicated way, depending on whichever needs you have. I want to provide some conceptual examples before I invite Zulily to stage to provide a very practical example of how data lake on GCP is useful and how that works kind of in theory and in practice. Really good example is replacing HDFS in a Spark and Hadoop cluster. Very common for people to have Spark and Hadoop clusters to store data and for them to scale that cluster out because they need to store more data in HDFS. As an example of how cloud storage can be a really good data lake in GCP, there's a Hadoop-compatible file system connector. Well, there's a connector that implements the Hadoop-compatible file system API available for Cloud Data Proc, which means that you can just read and write to and from cloud storage via Spark and Hadoop And you don't have to think about HDFS anymore. That also frees you from having to think about replication. It frees you from having to think about scalability. It also generally is incredibly performant. So you'll actually often see much better performance from cloud storage with Cloud Data Proc than reading and writing even to something like persistent disk. Doesn't necessarily mean that you would want to use cloud storage for everything in the sun. In some cases, temporary I/O may be more appropriate on local SSD. It may mean that you want to parallelize your workloads and avoid doing things like massive renames. But in general, the nice thing about having cloud storage as a data lake is you're no longer thinking about the biggest pain, which is that underlying file system and how you actually manage that file system to store your data. I mentioned consistency. This is a good example of why consistency is important. If you have multiple Spark and Hadoop clusters that are reading and writing from one bucket at the same time, they all need to be in sync in terms of what they see in that bucket. If they're out of sync, you're going to get different results. Say you're just dropping a new file in every second, and all you're doing in a Spark job is counting the number of files. Something that simple, if you don't have immediate consistency, you're going to get different results very, very quickly. So consistency is a really, really big deal for a data lake, and it's also a really good example of why cloud storage is a very, very good data lake. Mention segmenting data by classes. So people generally don't access all of their data at once. It's usually a very, very small portion of their data, which means that in a traditional world, in this case HDFS, they're paying one cost for all of their data, even though they're only accessing a small portion of their data frequently. With different storage classes, you can keep that frequently accessed data in something like a regional bucket, and then start segmenting your data to different classes depending on how frequently you think or you just know you need to access that data. You also have a choice of processing tools with cloud storage. So in this case, if you have data in cloud storage, you can read that data from Cloud Data Proc, you can read it from Dataflow, you can do federated queries on that data from BigQuery, you can analyze that data with Cloud Data Prep. In this example, say you analyze the data in Cloud Data Prep, and then you load a subset of that data into BigQuery. Very good example of a data lake in action. Very likely, all of the data that you would analyze with something like data prep, you're not going to just dump into BigQuery, because say you remove 15% of data because it's just not what you need to keep in BigQuery. In all likelihood, you don't want to immediately just destroy that data, which gives you a very nice separation between the appropriateness of BigQuery as an enterprise data warehouse and cloud storage as a data lake. You also have the flexibility of file formats in cloud storage and in general with data lakes. So in this case, say you have data that's Parquet and Avro and ORC. You don't have to think about different storage mediums for each type of these file formats. Within even the same folder, you can have files, all these file formats coexist. As long as the consumer knows what to expect or can introspect the files and deal with them appropriately, you're good to go. You don't have to configure your data lake and manage based on the file format. There's a lot of boxes on this slide. The important takeaway is cloud storage can be the central spoke of your data platform as a data lake on GCP. So for example, you could read data in batch from Dataflow or Dataproc. You can stream data from PubSub, from Dataflow. You can refine that data, put it in something like Spanner, BigQuery. But at the hub, all of your just data, either that's been processed or raw data, is inside of cloud storage as your data lake. With that, I want to invite our friends from Zulily to stage to walk through a practical example of how they built a data lake on GCP.
I'm happy to be here and share our experiences on board the GCP, the Google Cloud Platform 4 years ago, and specifically talk about what Google Cloud Storage meant for us and did for us among the other data products that Google has to offer. So this presentation is really talking about analytics and machine learning and how cloud storage can actually be a repository for doing all of that. A little bit about myself. I am Director of Machine Learning Data Science at Zulily. It's a loosely defined role. Machine learning data science can mean very different things at different organizations. But at Zulily, what this means is I work with multiple teams of data scientists, machine learning engineers, and data engineers to drive experiences that engage our customers, whether they are external customers or internal customers within the retail enterprise. So what's Zulily? Zulily is growing and thriving in its own category of e-commerce, and that's making shopping entertaining and fun. We present a third way to shop, which is discovery-based shopping, unlike brick-and-mortar retailers and traditional online retailers, which are intent-based, directed search-driven. Zulily is more about a browse and discover experience. So I said commoditized search. If you want cat food, you go search for cat food, you find a bunch of options, you pick the one you like, most relevant to your needs, and you go buy something. Zulily is not that. You think about Zulily as a newspaper or a magazine. There is a new edition every day, right? And the goal is we want to drive engagement. We want our customers to be curious about what do we have on the site today and come back to see what's new and fresh. So how do we do that? We launch over 9,000 products every single day through 100+ sales events on our website. We work with around 15,000 brands to make this happen. So it's an interesting business model, but what it requires is the agility and the nimbleness across the board, because we are really revamping, relaunching that same site over and over again every single day. And what it also means is we have to make data accessible to all of our partners within the organization, whether they are merchandisers who are working with the external vendors to get their products onto the Zulily platform, or they are marketing specialists who are trying to figure out what kind of ad campaigns to launch the same day, the next day, or the next week. Data is key. We also have 3 fulfillment centers in the United States, and so we want all of our associates in the fulfillment center to have access to data near real time and really drive their decision making using that data. So that was really the goal and how we are as an organization. So where is Zulily today? By the way, we launched in 2010, so we are a relatively young company, 8-year-old. But right now, 70% of our orders are actually placed through mobile devices. And 91% of our orders are actually coming through repeat customers. And that is the key, and that is really the focus of this talk. It didn't happen overnight. It's a process that we went through. So what was our journey, where we ended up here, and how did Google help in that journey to make this happen? We lost the presentation on that side. Okay. So 4 years ago, the business was growing, our product categories were expanding, the customer base was growing significantly, and that's the time where the company, we recognized that the structure we had in place did not meet the needs for our future growth potential. Right? That's where we started looking at what are our options, we started looking into big data, but at the core of it, we really wanted to make our own big data platform, right? We are a tech company at heart. We have a bias to build, a very strong bias to build. And from that perspective, we went back to the drawing board and said, hey, we want to build this big data platform to democratize data to all of our partners internally and also improve our customer experience to those who are coming to our site every day. So there were key components there. Back in the day, we had silos of data, unstructured data coming through clickstream, who's clicking on what page, what products are they viewing, which one they added to cart, what did they purchase, right? So all of that data is coming in, so it's all unstructured. On the other hand, we had transactional data stores, right? Every application, whether it's, the products customers are buying to, our marketing campaigns, all of that data lived in traditional SQL-like data stores. So we wanted to get everything together. Correlating something from a user interaction and unstructured data in the clickstream to something on a transactional DB was a hard thing at the time. So it was clear to us we had to get the data together in a single place and then figure out a mechanism to make it available to everyone and in a timely fashion. Scalability was important, reliability, durability, flexibility. Our business is really flexible, so we wanted to factor in all the flexibility upfront before we proceeded with anything. We had workloads with varying requirements. Some of them would be batch processes that we would run once a day. Some were every 30 minutes. But there were also a desire to get the data in near real time. So there was definitely a real-time component of that. And we wanted part of all of that data, which in the first place, we didn't know what data we needed and how we would use that data. Right? And that's where the data lake came in, the centralized data storage. Can we just put all of the data, park it somewhere, and over time, we'll figure out what's the best use of that data? And as we determine what that user scenario, the key scenario is that we're trying to target, that's when we will do all of the transformations and magic will happen on this data, and we will make it available in our big data warehouse, which will be available to the rest of the organization. And they will run their business from this big data warehouse. Data access and visualization is key. We do a lot of reporting. Like I mentioned, our fulfillment centers need to know what's the status of all the orders, how's shipping happening. Our marketers need to know how their ad campaigns are performing over the course of the day. Do we need to course correct something based on the data we are seeing? So there was a strong desire to get data as soon as possible and also be able to visualize it for easier consumption. And the core data services, which were really making that data available to everyone, whether it's a non-tech partner in different parts of the organization, or it is for consumption within the technology organization itself. So our journey was more around the centralized big data storage. We evaluated Google Cloud Storage. We really liked it. It supported all of our needs from the structured to the unstructured data. And like I said, at the time, we were not even clear. We had a few core scenarios we wanted to address, but we wanted to future-proof ourselves. So it really fit the needs. For the big data warehouse, we actually use BigQuery. And again, there we have over 100+ disparate data sources that we are actually pulling the data from at different time intervals. Some of them are near real time, some of them running every hour or every day cadence. So we've had to build some tooling around that. We built some capability internally that would actually synchronize the data from the disparate data sources, whether it's a SQL data store, no SQL data store, or just gathering all of the real-time clickstream and make it available in the centralized data storage that's GCS, Google Cloud Storage. And then we actually used a lot of static clusters in the beginning and then moved on to Google Dataproc to actually solve for some of the core scenarios that were critical for the rest of the organization. So what are the key data sets that we want to make available to the rest of the company that they can actually drive their day-to-day business from? So we use Spark and Hadoop to do all of the batch processing. In some cases, we use Spark streaming for real-time processing. And we made that data available in BigQuery. And BigQuery was great because the barrier to entry is low. It's not just limited to data scientists and analysts. It's a very easy SQL-like interface that I think half of our company actually, or more than half the company actually uses it. It's interesting because our PR team just told me, hey, I went into BigQuery the other day and I got this data. So that was pretty cool to see how people outside of technology are embracing it and being able to leverage to run their decision-making to run the business. So that's really what I was talking about, which is we wanted to make the data available as a self-service capability to the rest of the business. BigQuery is what we use, but really it was the data from Google Cloud Storage and manipulating, transforming that data, joining multiple data sets together to actually make something meaningful and compelling for our business stakeholders to consume. That is what is available in BigQuery, and they can do all of their reporting, dashboarding on top of that. They can actually get any intraday statistics that they need to answer some of the business questions. The other thing which was really interesting and was an outcome of this, we have a lot of inbuilt tools and applications. I mentioned we have a huge merchandising organization that's getting all of our vendors on board the platform, right? What we want to do is, over the course of the day, as the products are launched on the site, can we provide some insights to our merchandisers and our external vendors on, one, how their products are actually performing on the site, how much demand are they generating, what does conversion look like, and really give them the data and the insights they need to take action. And so we built some applications around that where this is an example of a merchandising dashboard. It's an application which is used by over 500 people within the company, but really this is driving them to look at the data and consume the data in an easy fashion, and then have something that's actionable as a result of looking at this data and the visualization itself. So once we rolled this application out, we really saw there was high engagement in our organization, and they really started to pick up on big data and the Google platform itself. The other thing I want to stress on is we have a dynamic business model. Our catalog is changing every day. We want to get people to come back to our site every day. So we do that with personalization, right? It's a one-to-one, hyper-personalized experience for every customer. So in that sense, we are actually serving millions of versions of our site every day. And we do it with the power of the data that we are gathering from all of the disparate data sources, trying to understand, what do our customers like, what are their preferences, and really hear from them and learn from them, and then take those learnings to drive their future experiences. So in this case, I have the same day, same time, there are 3 different customers who came to the Zulily site. On your left, extreme left, is a customer who buys apparel and fitness gear. In the middle was a shopper who came through a footwear advertisement and landed on our site. And on the extreme right is a customer who predominantly buys for her kids and home goods. So you can see the experience is radically different for all of our customers. And this is key to driving engagement, right? This goes back to, by doing all of that, we were able to get to 91% of our orders today are actually coming from repeat customers. We have over 6.1 million active customers today. Our number of active customers has grown 24% year over year. Our revenues at the end of Q1 had grown 17% year over year. Currently, we are at $1.6 billion. And one of the things I want to mention, I mentioned this in the context of the data platform itself, is the data lives in Google Cloud Storage, right? We are gathering all of the data. But even to power the machine learning and personalization experience, we are actually leveraging the Hadoop Spark ecosystem, the data proc clusters that Google has to offer, and using that, we are creating all the features that we need to drive the personalization experience. And again, depending on what kind of features we are building, what kind of transformations, the cadence will vary. Some are near real time, some are every half hour, every day, and so forth. One of the other interesting challenges here is people who work, familiar with the machine learning personalization recommendation system space is there is an inherent presentation bias in machine learning jargon. And what does that mean? That means is if a customer never sees a product, they're never going to click on it. If they never click into it, they're never going to buy it, right? So one of the places where we use Google Cloud Storage was also to address that problem of presentation bias. How do we bring transparency into what we do and how we do and share it with our business partners so they understand what is the exposure that personalization is driving through the customer base? And we did that by having all of our logs. So when we are serving, by the way, these are served in near real time. Right? So as we are serving these experiences to customers based on their latest and greatest data, we're actually logging those experiences, and we make those logs available in GCS, which helps us to actually mine those logs after the fact or during the course of the day at periodic intervals and be able to present reports and dashboards to all of our partners, telling them how personalization is actually driving exposure from our customers on the products that they care about, which was very insightful as well. So I mentioned briefly how it works. We're launching millions of sites every day. We receive all of that data. We process that data. This is where Google Cloud Storage comes into the picture. We are using Data Cluster to train our machine learning models based on the features that we are deriving from that data. And we are using that to inform the future experiences for our customers. It drives higher revenue engagement, but above all, it makes our customers happy. So there are other places where we are actually using my partners on the marketing side are actually using that data to actually figure out what the customer lifetime value is. And they do that by really looking at that data again and seeing, okay, who are our existing high-value customers? What were the behaviors that actually separate these from the rest? And as we are trying to acquire new customers, can we actually find who those high-value customers are based on the behaviors that they are exhibiting? So again, it unlocks, unleashes a lot of power, a lot of capability that you can build on top. So it's been a great journey. I talked about all of the positives. I do want to talk about, what are some of the key challenges as well. One of the things that James mentioned, I want to echo, which was a positive, and I missed it, was the strong consistency. We are actually gathering this data at scale. It's really high volume. We are looking at billions of key data points over the course of the day. So we want to make sure as one process is writing the data, while the other process is reading that data, it is the latest and greatest data. Right? So the immediate consistency in Google Cloud Storage is critical to enable that. So what are the challenges, or what are things that would be great to have? I mentioned at the beginning of my talk that this is more around repository for analytics and machine learning. If it's a repository, it has to have some mechanism of making that data discoverable. Right? Currently, that is one of the challenges we deal with, where there are different teams generating different data sets. How do we make sure that we are able to reuse some of the capability a different team has already produced? Right? How do we enable that ease of discovery in the Google Cloud Storage? One of the things I've loved working with the Google team is the collaboration that we work together to identify such problems and make improvements in the products. So that is a conversation we are having. I don't want to steal any thunder from them. But this is something that's critical to me personally, and I recognize that it is for other partners, other companies as well. The other is regulations, right? So we're living in a world where regulations are evolving, there are compliance. So how do we ensure that all of these data sets that we've accrued over time how easy is it to incorporate a new regulation, new compliance, or legal clause, right? That's one of the challenges where we had to rethink. Again, we are a relatively young company, just been there 8 years. We never had to deal with decades-old data, but that's something that we've started thinking about now is what is that data retention policy and how does that play into Google Cloud Storage? So for people who are actually onboarding Google now, I think that would be one of the things you should just bake in and think about now versus later. Data annotation duplication sort of ties into data discovery, but this is, again, more around duplication. Are we repeating the work? Can we actually take advantage of the work that somebody else has done to generate a data set and use that instead? So those are the things that I think are really top of mind for me, and I would love to solve, and I would love to solve it in collaboration with Google. So I will pass on the mic to James, and we will be open to questions in a bit.
Thank you very much. All right, so before we leave and take questions, and we have a few minutes for questions here, I wanted to leave you with a few resources that you could look at, that you could get involved with for more information. If this was interesting, if this topic is near and dear to you, we wanted to point you in the right direction. So there is a talk. It is happening. It's actually after this talk. It's an I/O talk on moving data to the cloud. It's going to cover much more specifically how you actually do something like move large sets of data to cloud storage. If that topic is interesting to you, please do check it out. There's also a lot of documentation on the cloud.google.com site for building a data lake, thinking about the lifecycle of data on Google Cloud Platform, and using data in cloud storage as a data lake with our big data tools. You also find that a lot of the products like Dataproc or Dataflow, BigQuery, actually have their own documentation as well for working with cloud storage for usually more specific use cases, whether it be something like Spark Streaming or streaming in Apache Beam or doing a federated query in BigQuery. So if you are curious on how to use cloud storage as a data lake with product X, Y, or Z, I would actually recommend look at the documentation for that product, and usually you will find that